Okay, so we've got another week of our review questions. These are the topics, Hegarty Maths clips. If you want to go back and revise any of them, if there's anything that you don't feel confident on, anything that you're not getting the correct answers on. Hopefully you've tried the first set of questions already. If you've not, I'd encourage you to try and do that now, or pause the video when I turn the page and try them before you see me going through the answers. And hopefully then me going through the answers will let you know exactly where you need to maybe adapt your thinking, or if there's anywhere where you're not sure about, and give you that reassurance. Okay, so our first topic is multiplying and dividing in standard form. It should say standard form there, and these instructions should say to calculate those. So calculate in standard form, 2.3 times 10 to the power of 5 times 5.6 times 10 to the power of 7. Okay, so if we're given this in a non-calculator paper or in a calculator paper, our method is broadly the same. And broadly the same depending on what calculator we've got. So some calculators will calculate in standard form for you. I'll just show you that mine here will. So 2.3 times 10 to the power of 5 times 5.6 times 10 to the power of 7, and it will tell me my answer should be 1.288 times 10 to the power of 13. If it's not a calculator paper, or if your calculator doesn't calculate in standard form like this, your method will be brought like the same whatever way. It's just doing this decimal calculation that might be different. So the first thing we want to do is do 2.3 times 5.6. So I'm going to do that quickly up here. So I'm going to do 23. I need to give myself a little bit more space. 23 times 56. So 6 times 3 is 18. 6 times, so I've got a 10 to carry across. 6 times 20 is 120. So plus the 10 is 130. 50 times 3 is 150, so I've got 100 to carry across, and then 50 times 20 would be 1000 plus this 100, so 1100. So that would give me a total of 1288. Okay, so 23 times 56 is 1288. So 2.3 times 5.6 is 12.88. Okay, if it was a calculator paper, we could just do 2.3 times 5.6 and get that straight away. 10 to the power of 5 times 10 to the power of 7. Remember our index laws. So we're multiplying, so we add the powers. Our bases are the same, 10 in both instances. So we can add the powers together to get 10 to the power of 12. Well, this isn't the answer that it showed me on my calculator. You can see it's not quite the same. The reason is this isn't in standard form. Because to be in standard form, the number needs to be between 1 and 10. So instead of writing 12.88, I want to write 1.288. But I can't just change the number, so I need to write, well, how these are related. So instead of writing 12.88, I'm actually writing 1.288 times 10. 1.288 times 10 is the same as 12.88. Then I'm multiplying by 10 to the power of 12. So altogether, I've got 1.288 times 10 times 10 to the power of 12. So altogether, 10 to the power of 13. Okay, if you're not sure where I got that 13 from, 10 is the same as 10 to the power of 1. So I'm adding those powers together. Okay, when we're dividing, we're using a similar idea. So I'm doing 2.4 divided by 8. I could use my bus stop method for that. You'd get 0.3. 10 to the power of 5 divided by 10 to the power of 7. So again, my bases are the same, 10 in both instances. I'm dividing, so I want to subtract. 5 take away 7 is negative 2. So I've got 0.3 times 10 to the power of negative 2. Okay, still not in standard form. This number needs to be between 1 and 10. If it was, I'd just leave it at that. I'd be in standard form already. Because it's not, I need to change it. So instead of writing 0.3, I'm writing 3, and then I want to divide by 10, but I don't want to write a division sign. So what I'm going to do instead is multiply by 10 to the power of minus 1. Remember, that means to do 1 over the negative indices. Do revise negative indices if you're not sure what's going on here. Okay, so that is the same as 3 times a tenth, or 3 divided by 10, which is 0.3. And I've still got times 10 to the power of negative 2 to add on. So these expressions now are exactly the same. I've got 10 to the power of negative 2, but I've replaced 0.3 by the equivalent expression 3 times 10 to the power of minus 1. And that gives me 3 times 10 to the power of negative 3, because I'm multiplying, so I add the powers. So 3 times 10 to the power of negative 3. Okay, lowest common multiple. Okay, that should have been changed. Shouldn't say the highest common factor. Sorry about that. So find the lowest common multiple of 120 and 210. Okay, again, this could come up on a non-calculator paper. We've already practiced prime factorization, so I'm presuming you know how to do that. So I want the prime factorization of 120 equals shift fact. So that's 2 cubed times 3 times 5, and of 210. So 210 as a product of prime factors is 2 times 3 times 5 times 7. Okay, with smaller numbers, if I'm finding the lowest common multiple, I can just list them out. I don't really want to be listing loads of multiples of 120 and 210 and hope that I get one the same at some point soon. So to find the lowest common multiple, I need 120 to fit inside the other number, and the same for 210. So I need to make sure all of these things that are in the prime factorization are included. So for my lowest common multiple of 120 and 210, I need some 2's. How many 2's do I need? Well, 210, I need 1, 2, 4, but that wouldn't be enough to get me 120. I need 3 2's there, so I need to have 2 cubed. I've got 1 3 in both, so I need just 1 3 to cover both. 1 5 in both, so I just need 1 5. 120 doesn't need a 7, so this number would already be a multiple of 120, because I've got 2 cubed times 3 times 5. In fact, it would be 120. But to make it a multiple of 210, I also need to have this 7 in here. So we've got 210 is a multiple of this now, because there is a 2 in it, there's a 3, there's a 5, and there's a 7. And now I can just put that into my calculator. So 2 cubed times 3 times 5 times 7 is 840. So it's sort of the opposite of what we did with highest common factors. With highest common factors, we were picking out just things that were in both products of prime factors. For lowest common multiples, I'm picking out just enough to cover both of the prime factorizations. Multiplying and dividing fractions, this is something generally we've been very good at, so hopefully we will continue to be good at. We just need to remember when I'm dividing by a fraction, I multiply that fraction by the reciprocal. So instead of dividing, I multiply by the reciprocal of 5/6, which is 6/5. And then if I'm multiplying fractions, I multiply the numerators, 2 times 6, and the denominators, 3 times 5. And I've just written that out there before I've multiplied them. I could have just written 12 over 15 to make it easy to spot where I can cancel out. Now 2 doesn't have any common factors with the denominator, but 6 does. I could divide 6 by 3 to get 2, and 3 by 3 to get 1. So then instead of having 2 times 6 over 3 times 5, I've got 2 times 2 over 1 times 5, which is 4/5. Okay, for the second example, we're multiplying, so we don't need to do any reciprocals this time. But because in a sort of uncommon convention for maths, there's a hidden addition sign. Usually if we have hidden signs for multiplication symbols, here there's a hidden addition sign. 1 3/8 is 1 plus 3/8. 3 2/3 is 3 plus 2/3. That means that I can't just start multiplying these together, because actually this addition takes precedence over this multiplication. So there's sort of brackets, imaginary brackets around here, where we've got 1 plus 3/8 in brackets times 3 plus 2/3 in brackets. The easiest way to deal with that is to convert them to improper fractions. So 1 3/8, well, one whole number has 8/8, plus our 3/8 is 11/8. 3 2/3, so 3 whole numbers. So one whole number has 3/3. 3 whole numbers would have 9/3, plus an extra 2. We've got 11/3. So we've got 11/8 times 11/3. So we've got 11 times 11 over 8 times 3. And this time there's no common factors that I can cancel out. 11 doesn't have any common factors with 8 and 3. So we're just going to get 121 over 24. Okay, and if we want to then write that out as a mixed number, I'd be thinking about how many lots of 24 I can fit into 121. And in fact, I know that 24 times 5 is 120. So I could split this 121 into 120 24ths plus 1 24th, like that. And 120 divided by 24 is 5. So it's 5 and 1 24th. Okay, nth terms of quadratic sequences. So here I'm being asked to find the nth term of the sequence 2, 9, 18, 29, 42. You might remember in last week's, I started off by looking at the differences between consecutive terms. I'm going to do exactly the same thing here. The difference this time is that we can see the difference, overuse the word difference, is changing. So I'm adding 7, then 9, then 11, then 13. If that happens, we know we've not got a linear sequence because it's not got a common difference. So we start working out the second difference. Plus 2, plus 2, plus 2. If that second difference is the same, we've got a quadratic sequence. And the first thing that I'm going to do here is just divide that second difference by 2. That tells me what coefficient of n squared I get. So a quadratic nth term is an squared plus bn plus c is of this form. So my nth term is going to look like this. This is telling me I want one lot of n squared. Okay, I still don't know what that b and that c are going to be. But what I can start doing is I can start using a table to work out what I've got and what I want, what I need. So what I've got is the sequence n squared. Okay, and if I look at the first, let's just say the first 4 terms. The first 4 terms of n squared are 1. 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. Okay, so I've got the sequence n squared. We can see that's not the sequence I wanted. What I wanted was the sequence 2, 9, 18, 29, and so on. And I've left a gap there so that I can put in what I need. Well, I want to add 1 here, add 5 here. 9 plus 9 is 18. 16 plus 13 is 29. This is what I need. I need to add this sequence to the sequence that I've got, to my n squared. What's the nth term of this sequence? It's going up 4 each time. So 4n plus or minus something. 4n would give me 4, 8, 12, 16. I want 3 lower than that. So it's the sequence 4n minus 3. So I have the sequence n squared. If I add the sequence 4n minus 3, I get the sequence that I want. Adding these two gets me the sequence that I want. So I need to add these two expressions together to get my nth term. So it's n squared plus 4n minus 3. Okay, I know there was another method of doing that on Hegarty Maths that some of you liked. I do prefer this method, but I've explained in class for reasons why I prefer this method. But whichever method works for you, if you are happy with that, and more importantly, if you can remember it, then choose to use that method. The reason why I prefer this one is because I think it's easier to remember. It bases itself more on other things you already know. Okay, skill number 5, this one should be nice and simple, substitution. So substitution, I'm basically just replacing the letters with numbers that I'm told they are worth in that circumstance. So 2x is 2, 5, but there's a hidden multiplication here. It's 2x is 2 lots of x, so 2 times 5, plus 3 lots of y is 3 lots of 2, 3 times 2. And now I follow orders of operations. So I'm doing my multiplications before my addition. 2 times 5 is 10. Still got that addition. Plus 3 times 2 is 6. 10 plus 6 is 16. Nice and straightforward. Substitution questions can look a lot harder, and we're sticking with some simpler examples here. But they boil down to the same skill. Replace the letters with the numbers that you're told they're worth, and then calculate everything, but make sure you write things down accurately. Don't change the order of anything in the expression. You're writing down things in exactly the same order, just replacing the letters with numbers, and if you need to, writing in any hidden operations like hidden multiplication signs. Okay, last topic for this week's set of questions, estimating and rounding. Should be quite straightforward. The first part, rounding 3.2643 to 1 decimal place. So my first decimal place is this 2 here. So I'm either going to be rounding down to 3.2 or up to 3.3. To help me, I need to work out what's in the middle of that. Well, what's in the middle is 3.25. Is 3.2643 above 3.25 or below? Well, this has got 5/100ths. That's got 6/100ths. So it's above. So 3.2643 would round up to 3.3. Okay, and you might be used to, well, I look at the next column. If it's 5 or above, I round up. This is your visual demonstration of why that works. Because if this is 5 or above, it means you're in this half. So that midway point is always has a 5 in the next column because we work in a base 10, a decimal system. Okay, last question. Estimate the value of 2.6 times 43.3. Most of the time when people lose marks in this in exams, it's not because they don't know how to do it, it's because they do too much work. The idea of estimating answers is that it should be quick. Okay, it's a crude, quick measure to know roughly what the answer should be. That is actually useful in other questions. When you think, I'm not quite sure whether I've done that right, you can estimate your answer. Check that it looks roughly right. The idea is we want to round everything to one significant figure. I'm going to use this squiggly equal sign to mean approximately equal to. So 2.6, I'm rounding to 3. 43.3, I'm rounding to 40. I only want one significant figure, so one non-zero digit in each of these terms. And 3 times 40 is 120. So straightforward, it's as easy as that. If you start writing down anything more detailed, you're losing marks. If you need to write down any calculations in your working out, any sort of column, grid multiplication, you're doing it wrong for estimating questions. Okay, so that's the 6 topics for this week. Try and work through one page a day. Send your answers to me if you want me to have a look at them to check over any of them. If you've got any questions, please do ask me. Any particular topics you're stuck on, look on Hegarty Maths, watch the video back again. I'll put the answers at the end of the week, and good luck with that.